Good morning, good evening, all of you, and welcome to the webinar session on linear regression with R. Of course, but before getting into jumping into linear regression, we'll talk basics of the analytics and bit about R, and then we'll do some hands-on using R. All right, so I have structured, I think that this session would be into three parts. One, we'll talk about everything, but not, of course, in the first part, not linear regression, which would be like what is data mining, business analytics, stages of data analytics, R and machine learning overview. This should be the first part. Then we'll get into Q&A, question and answers, where in fact, wherever you have questions, you guys can keep on writing. And once this first stage is done, I'll take your questions. Then we'll do a hands-on. We'll understand linear regression and understand the application of linear regression. It's a real-time case study that we have chosen for you. Okay. Okay, so I've already spoken about the objective of the session. We'll directly jump into the context of it, this data mining and why this is so much spoken about. Okay, so what has happened during this this last maybe 10-15 years? There has been a revolution. So revolution is in a sense that the cost of storing data, of course, has gone down. The cost of processing has also gone down, and organizations have started realizing that they have huge amount of data residing with them. Since all those things were coming and there was a need to scale up decision making in business, so there needs to be one intelligence unit in business where the decision making for achieving business goals need to be made scalable. So that was genesis of so-called data sciences today. But was it not done previously, and what's new about it right now? Okay, so before, of course, it was done. It was known by different names. But what has happened, there was only limited sources of data, as in whatever is residing with us. But in today's world, because of this social network, because of this machine sensors, because of the mobile phones we use, because of so many such sources, there is a splurge in the data. There's a humongous amount of data. And we have also started looking into those connections among the data set. For example, if a person goes to a store and buys something, so what could be the time that sales will happen? As in, if anybody of us goes to a retail store and will buy something from there, so store wants to know that what's the best time which I or any of us would be getting to the store. So how he can know it? It is not just only by looking into the historical patterns that he would see footfalls into his store. He can also really go and analyze the social data, can also look into the various expenditure cycles, that it's not only this store, consumer can have other expenditures. Also by looking into the credit card data, one can understand that what's the credit worthiness, if is actually how much will you spend in buying any good from my store. So there's a lot of questions, and because there is different data sources, that links can be established and more precise decisions can be taken. All right, so generally this first slide we talks about giving a definition of data mining. Of course, you know, the definitions, business analytics, data mining, data sciences, you would really see they are getting into each of the territories. But it is just what I have seen is generally up to us, you know, from where we are like drawing the lines. Okay, so we'll just let's get into the scientific definition of it, accepted definition of it. So data mining is a process of finding correlation of patterns among dozens of fields in large data generated from business. Okay, so a little correction here in this line: large data generated from business. It's not only business; it's like anywhere we can think of that data. So data, that any kind of data that can map the person, that can really creates a personality. You know that without knowing the name and without looking into the person, without talking to the person, you can know that what are the various characteristics, what are other behavioral traits of that particular consumer, what could the potential, and if it is maybe anything you can think of, right? So it's not only business, it's everything. It's mobile phones, it's whatnot. Okay, so here we have we can really understand into these three parts. But not only this, what we can do, we can understand this cycle, maybe in a various more steps. But still, just to start with, let us understand how do we define data. So data can be any facts, number, or text. Okay, so numbers we understand, sales purchase numbers, we understand number of clicks over website, we understand number of friends over social network. So all those things we understand. But what is to do with text? Let's talk about it. So text is maybe a certain feedback which is given over a .com website. So what can we do with it? So there can be a lot of analytics which can be done over this text analytics. So one is, maybe we can check the sentiment. Maybe we can understand the voice of customer. Is he happy about the service, not happy about the services? So that could be one part of it. Maybe we are very good with marketing and we have generated a very good revenue today, but if there is not very positive sentiment in the consumer community, then business would not be doing good in coming times. So we really need to be cognizant. We need to really understand, what customer is talking about. So in fact, there is a large research field, which is a new field of research, which is like natural language processing. People there are researching a lot of different kind of algorithms, different techniques to understand the sentiments, to understand what more sense we can get out of this this textual data. Okay, and any facts. See, fact can be anything. For example, it's a FIFA World Cup. So what can happen during that? Maybe during that particular event, sales of jerseys going high, number of downloads for a football app is high, or those kind of activities are surged. So this event, which is a real event, that is also impacting sales in stores of events which are related to this. Is also impacting the app's activities. Also, it can really get to a fact that the person who has scored a goal in that match, what brand shoes he's wearing. It can really get down to that level, and that kind of marketing can happen. So all those things. Okay, so and when we during using all these different data sets, when we make relationship, when we see patterns, then we can say that that's an information we have derived out of this data. Okay, and finally this information this can be converted into knowledge. For example, maybe the example which is given here, it is sales in off season may help to start some offers in that period to increase sales. So a lot of different information. So one is maybe off season sales, the sale is going down, and what person would be surfing, would like to surf. Can we fix some kind of discounts, can we some kind of schemes, getting all those things together, these both pieces of information together, can we get some knowledge? Knowledge is can be used for making decisions. So all those things can come into picture. Okay, moving to the next slide. So, which I have already spoken about, why is business analytics getting popular these days? So you would see this cost of storing data. I think everybody can relate with this. Now you would see the same configuration laptop you buy today, and in fact, the same dollar price which you would have bought some time back. The configuration of a laptop or computer would be very less. In fact, just see the HDD, the hard disk drive you can buy today, and just you can buy maybe 2 and 3 years back. So you see that the dollar price remains same, but it can store more and more of the data. You can see any storage device, you can see hard disk, you can see a pen drive, and same is can get with this kind of commodity hardware, with those server plates, where a lot of servers can come together and form a big cluster of a big warehouse of the information. This is one part. Also the cost of processing. You would see the RAM where all this information is getting processed. That's also going considerably down. And both these independently has generated altogether a different field of business application. So if I would name, so cost of storing data going down gave rise to Hadoop, which everybody is familiar. I hope everybody is familiar with it, with like parallel programming and all those things. Hadoop, and this cost of processing data going down give rise to something known as Spark, and which is the new buzzword in this era. All right. In fact, these two combined together is also fueling the next generation, the next generation of decision making. So that's the idea. Okay, moving toward the next slide. Here it is the stage of analytics, and this is the whole cycle and to and through how this data would go. But I would really take a step back here and would just maybe start typing here a few things so that we can understand. So first step is getting the data. So maybe getting the data from various sources. In fact, much before that, we need to understand what business decision we want to take. So the business decision could be related to our larger business goals. So what are larger business goals? Here, business goals. What are these? Maybe one could be reducing the operational cost. Second could be like increase the revenue. Third is increasing the brand awareness. So all those things could be business goals, and there could be different decisions that can be taken. For example, if we talk about reducing the operational cost, then decision could be maybe optimizing the warehouse, maybe optimizing the real estate where we are opening our stores. So selecting those places where the rentals are less. So all those things, the business decision can be taken. Then is followed by data. So why data here comes at 3 is that it is not about any data, because there is so much data, we really need to be specific. Maybe few things here and there could be okay, but we cannot be going entirely tangential. Suppose we were analyzing something on .com sales, we cannot really go and take the brick and mortar, only brick and mortar sales. We need to talk something which is online, because online activity, online behavior of consumer can be different than to the real ground. So that's why we need to start with our business goals, then business decisions, which here we are representing in a block as a business understanding, and then comes out to be data, what data we have. So data, we need to do data understanding. This process is called EDA, it's called exploratory data analysis. In simple English, you can understand that me talking to the data. So how do I understand the data? How data is structured, how data is flowing in, is it real time, what's the refresh time of the data, what are different fields where data is storing, what's our daily record refresh time, daily new records coming in, all those things. Let's understand the data first. Then comes the data cleaning. So here you would see we are calling data preparation. So data cleaning, and of course transforming. So let's take this one by one. Data cleaning is something, suppose we have data maybe in some kind of delimiter, maybe it's pipe delimiter, there's a question mark delimiter, or maybe it's in single quotes. But in order to machine to understand it, we need to read that data in a form that machine understands it. So we need to clean that data, and maybe not everything in data could be useful to us. Maybe it is something data is flowing from some web API, but is it like all HTML file would be useful for us? Not at all. We will looking for some terms here and there from it. So we're gonna clean the data. We're gonna parse the data. And what is transforming? Transforming is, suppose there's a statement in the data set that sales on Monday is 20,000 US dollars. So this everything would be read as a string or maybe a set of characters. But in order machine to understand that it's a number, we need to parse that particular piece of information and transform it to a numeric, into maybe an integer or a factor, whatever way computer or a machine understands it. So that is a stage of data preparation. Of course, once we are maybe done with any of the step, if we really think, after maybe doing EDA, we think that we want to go back and it really enhances our business understanding. We need to go back and forth, need to come, and finally this stage is our data is all set to do modeling, like we have mentioned here. So it's all set to do modeling here. Here we'll do modeling. So modeling is it's statistical modeling. Let me put it this way. It is statistical modeling. So why do we do modeling? Data have some patterns, and those patterns can be repetitive. Data can give us some kind of information. Data can give us some kind of information which can be repetitive, which can be replicated. Suppose, let's take an example of modeling. Suppose I want to take some decision. I have a retail store, and I want to understand what I'm going to do with my business tomorrow. And is it like reducing the operation cost, or is it like I want to talk about the revenues, or what I want to take some branding activities, what I have to do? So first of all, I want to understand what is my total sales today and how it is trending, right? But knowing today's sale or knowing today's brand awareness wouldn't be helpful to me if I'm taking decisions today for tomorrow's or maybe for next quarter or maybe next year decisions. If I have to take something, because Rome was not built in a day. Similarly, if I have to build a new store, if I have to do something, I need to start doing it today onwards. If I need to do some new .com, I need to get up. I need to start thinking. I need to start planning today itself, right? So based on today's data and data till date, the historical data, I want to make some, I want to extrapolate my trend. I want to do some kind of forecasting that how sales will impact maybe vis-a-vis different geography or different regions. So it could be, a region A could be has more potential than region B. And maybe historical data could say something else, that sales in region A is going down, or maybe it's not that good with the region B. But tomorrow it could be something different. So I need to take decision accordingly. That's why I model my data, and I make my model learn from that historical data and forecast it for tomorrow, day after tomorrow, or whatever day I want to do it. Right? So the different modeling techniques we apply to do that. All right. And finally, once I'm done with this statistical modeling, I do evaluation. So what is evaluation? So in word of forecasting and modeling, machine learning, we need to understand one thing, that we really cannot claim 100%. We cannot say that that my whatever model I have done, it is 100%. I always can be relatively better. Maybe the model which I have made today, it is not that good, but I really can improve this model. Getting to 100% would be near to impossible, yes. And so we need to do the evaluation. I would see that what is the accuracy of this model. You would see in hands-on how we're going to do that evaluation. So those things would really come into picture over here. All right. And finally, once you have evaluated and you really think that this model is not that good, and maybe the accuracy is going down, then you really can go back from here and just establish your understanding again, then come down to the whole cycle. Finally, once you are convinced that this model is giving me good kind of accuracy, then you are ready to deploy it real time, and that model really can help you in assisting your decision making process. Your decision making process in business could be scientific, and once it is scientific, you really can scale it up your decision making. Because if you imagine what's the frequency of decision making in your business, it's every second. At times maybe your CEO in a company, when they're talking to different VPs, it's like they need to take decision every now and then. Is it like maybe for some inventory, for putting on some networks, maybe some admin decision, HR decision, a lot of decisions if you can think of. An organization is run on lots and lots of decision. So all this decision cannot really come out from plainly the experience, plainly from the hunch. It really needs to have some scientific process. So that's why this thing, the modeling, this thing, business analytics, being established. All right. Okay, then let's move ahead. And once this theory is clear, how do we do it? So we have few computational tools. One of the very popular tool is R. R, of course, R. What is R? And R can be anything, whatever is written here. Yes, R is a programming language. Whatever you can think, we can program. And the way maybe you are programming in Java, C, it's object-oriented. You can do the same way here also. And the statistical analytics, the way you are doing in Excel, you can do it here also, but excluding the limitations of Excel. Of course, once we do it, you will figure it out. There are lots of things we can do here. And data analysis software, yeah, it really fits on any of the thing. In fact, R is a revolution, which is really going over the website, which is really going over this open source world. There's a whole community around it, which is contributing to it, and people like us are contributing to it for benefit at large. So this is much. This is lots of there's lots about R, not only this. Okay, so a few characteristics of R. As we understand that R is a vectored language. When I say vectored, it means that it really operates on arrays, lists, and vectors, which predominantly it's built over. It's not built for scalar kind of manipulations. It's typically used for that. And it can also be integrated with visualization tools. It in fact itself comes with a visualization tool called R Shiny, and it can sit over Hadoop and do that manipulation, whatever is like extracting data from Hadoop and doing those processes. So it's like that. In fact, it's most important is free and open source, and we really can. There's no cost of trying different things over your own computer. But the only thing is that we really need to understand the way to approach it. And in fact, that's why we are here to help you out. Okay. So moving to the next, data visualization in R, you would see this is one of the visual map which is created by R. There are a lot of packages. So this R library, there are a lot of packages which R come up with, and it is readily available over the web, online. We can download, we can install, and we can use it. So it's rich in visualization also. In fact, I can really, anybody here can define the merits of visualization, why it is important. Because looking into a big set of tabular numbers, we cannot understand what a trend and everything is about. But when we look into a visual, it really becomes obvious, where this data is moving, what particular business is behind this, right? Okay, different domains where R is used for. It's just a handful of places: telecom, pharmaceutical, financial services, life sciences, education. Let's take one example from each domain. Telecom, maybe that's one. So if it could be, if you want to identify which customer would churn tomorrow, you can really model around that. And what you can do with it, if you know which customer will churn, maybe you can do every good thing to stop that customer, because acquiring new customer is expensive. So you can maybe really share those discount price with them. You can share that operation cost with the consumer and transfer to him as a benefit, so that you can sustain that consumer. Pharmaceuticals, getting the drugs in the market, a scientific process, doing those analysis, whatever surveys and whatever surveys you are doing around. Financial services, one good example is share market. If you want to predict how your share prices would be tomorrow or maybe day after tomorrow, look by just looking into historical data, you can model that around. Life sciences, yes, there's it's a very great application of genomic mapping. You're mapping your DNAs and all that things, genetics and all is going around, and everybody is after this today. Education, in one good example is learning analytics, focusing on a student sitting in class in specific tailored kind of delivery method can be used for each and every student in a class. So there could be lots and lots of examples. I just mentioned very few of it. Okay, and moving down to the next part, which is machine learning. So do not confuse with this term. Here in this place, when we are talking about all this sequence, what we talk about statistical modeling, this particular term. You can easily fit this machine learning substitute with statistical modeling. If you ask me what is the difference, so there is difference is only the terminology. All this computer science people, they call this modeling as machine learning, and statistics people call it statistical modeling. That's what I have observed. So that's the only difference. And there, to understand it, there are two types of machine learning. One is supervised learning, and another is unsupervised learning. All right. Okay. So maybe before I just talk about this machine learning and that moving to linear regression, let me call this end of the stage one. Maybe a slide before that. I just want to look into your questions. Okay. So if somebody has, let me know. Let me see. This couple of. Okay, I can see it from Pallav. Pallav is saying, okay, voice is breaking. I think it's good with other people. Please check your connection maybe from your side. Okay, I just have one more question. Is that what is modeling? I think by the explanation. Okay, it's really breaking a bit. Okay, so few of the places it's going good, and feels. All right. Okay, so right, I guess guys, please check your connections from your side. Few of the places I can see it's a good response. My voice is going good, and few of the places a little breaking. A few as in couple only, I guess one or so. Okay. And so one question is, what is modeling? I think I just had cleared this particular question when I was discussing, and was a time back. And same question is like, what is machine learning? In which programming language we can write? Okay, so our machine learning is just same thing. Which so we'll do one case study today. We'll just do one statistical modeling technique, apply one statistical modeling technique today. So modeling, that's what I told you. It's as simple as understand forecasting. Maybe forecasting, or just to understand the nowcasting, maybe what is happening today, or maybe what is happening tomorrow, just based on the data. So if I know how my numbers will turn out to be tomorrow, I can take good decision today. That is modeling. And same is machine learning. And what language you can use? There are lots of language in today's world. You can write your machine learning algorithm. One very popular is R, and there's none close to it. Okay. Second is your, of course, Python is slowly catching up. In fact, quite a bit. It has been there, and there are a lot of packages in Python, pandas, and all that. We're doing good. And since the advent of this big data, we also can see that all those things can be done using now Scala, which is over Spark, and there are lots and lots. This field would be evolving. This open source world, you would see a lot of contributions, so it would be slowly evolving. But R is very popular. Okay, and another question is. Okay, so one question we have, what are the resources from where we can learn R using real-time data sets? Okay, so Mukul, we have lots of resources available online. Okay, that you can learn R, but it's like so much segregated that you really need to have some fundamentals. So I would recommend maybe start by reading a book, or just start understanding business analytics first. In fact, in the end of the session, I will also tell about how in Edureka we are also taking that session, how we are building those basics from down to the top, and then talking about machine learning in the end sessions. All right. Okay, so this question's done. Let me take the other one. Okay, so we have, okay, can you please go just once to the slide explaining the cycle of data analytics? Sure, I would really move to that. Let me go there. If you have some question maybe related to this, let me know. In fact, this would be a recording. Later on would be uploaded over the website. You can download it if you can even like even ask for. You can pause it and later look into it. There shouldn't be a problem. The next question is, which programming paradigm does R fall into? Okay, so yes, right, are we called a vector programming language? It is not the previous word which we talked about, object oriented and all those things. We of course can do all those things, but it's a vectored language. It is a language which is developed for statistical computing only, where we can scale up our statistical models. So think of it this way, right? So next is Kunal is asking, is there a Java-based machine learning language in the market as well? Okay, so Kunal, whatever is being like built, Java is a component of most of it. It's a basic and most of it. And what Java is not good at is the environment of this machine learning, this statistical learning, where you have those ready-made tools, ready-made packages we can download and start implementing it. Because as a business analyst, maybe what is the mechanics behind it. I'm interested in interpreting my output, relating it to business. So Java maybe at all not can help you with that. But everything is based on it. There are a lot of code snippets available online also. Even we can look into the algorithm can really implement over Java, but it is not like R. We don't have that rich environment of statistical computations. Okay, next question we have, how many skills need to know become a data scientist? So plainly, to become a data scientist, we should know, one, have a good understanding of our business domain, which really can come with experience. That's one part. Second is we want to know this statistical modeling and statistical computations. We should understand those things. And third is the technology. So it's a combination of these three things. Okay, so one question is, R is a programming or a statistical technique. So R, as I've spoken previously, R is an environment. R is a statistical programming language. It's not just a technique. It is a conglomerate of all the techniques coming together, where we can use our systems to scale up those statistical modeling. It's a software. Okay. So one question we have is, can we differentiate between Hadoop and Spark, and where does statistical modeling language like R fits in? So yeah, Hadoop and Spark, yeah, since I mentioned the words, so of course, just to understand that whenever we are doing computations, If it is over disk, it is Hadoop. And if it is over memory, it is Spark. And R fits in, so R, these both the things, Hadoop and Spark, are the place for storage and processing. Is it the data processing, the basic processing, the extraction and grouping, like that. But R can sit over both of them to run statistical model. Okay. Okay. So guys, I think okay, we have lots of question now. Okay, then let's go ahead, and then we'll come back to the questions. Okay. Okay. So this is machine learning, and we'll be talking about machine learning. So there are two types of machine learning. One is supervised and there's unsupervised. So as the name goes, we really can comprehend by this. Supervised learning is when we know what our target variable is, what we have to model. So we have a known data set and we have a known kind of output that maybe it is sales or footfalls, anything which we want to predict. So that is a supervised learning when we really do not know what kind of output it can be. So we use a set of unsupervised learning techniques. And the second slide talks about different algorithm techniques. So supervised learning, support vector matrix, random forest, decision trees. In unsupervised learning, there is quite a clustering, hierarchical clustering, k-means clustering, fuzzy clustering. So all these are different techniques. And which technique fits in where? It's like one, we should look into this input data set, where what our characteristics of our data is, and based on that we need to take a call that which model will fits in where. That's that's where a good statistical sense would come. And second is if two models are close, we can really get the output and we can see the error part where there's the least. We can do that. Okay, guys, moving to linear regression. Okay, so linear regression technique, I think it's best if we do it over little hands-on. So what it is, it's a approach modeling technique, where one variable is dependent upon other variables. For example, maybe sales. Let's say it is a dependent variable. We need to predict sales, and it could be dependent upon how many. It could be really dependent upon number of .com clicks. It could be dependent upon number of footfalls in my store. It could be dependent upon number of my social share. It could be dependent upon my branding activities, my different events I do. So one variable, sales, it is dependent upon lots and lots of variables, which those variables are called independent variables, and the variable which I'm going to predict, it is my dependent variable. Okay. And if it is only like a case of we have one explanatory or independent variables, we call it simple linear regression. Okay. And the other case, when there are more than one, it is called multiple linear regression. This is just a basic theory of it. And so as I told you, there are like many practical uses, and one, the application which we have discussed. I think let's move into the hands-on. Okay, just before that, there's one equation. How it would be represent? It is a simple linear regression equation where y is equal to a plus bx. What it means is that based on this variable, so a and b are the constants which we would be knowing, and when this unit this x variable change, it would be impacting my final variable also. So it is of this format. If it is multiple, then it is y is equal to beta 1 x1 plus beta 2 x2, so on to beta n xn plus c. So c is the intercept. All right. So it could be more than one. Okay. So linear regression case study. We jumping into the question directly. The problem statement is computer manufacturing company is trying to analyze the data of the price of computer with another independent variable like CPU speed, hard disk, RAM, screen size, CDs, maybe CD present, yes or no, produced by premium company, yes or no, and so on. So there are a lot of variables. Okay, so based on this data, company wants to decide on the price of new configuration of PC. Okay, so we understand this. This is our data set. These are price column, and these are different columns, speed and all those things. So historically, we have the data, but suppose tomorrow, if so historical we have data. Suppose tomorrow we want to decide on some price on of one PC, price of this PC. How we can do it? So we can consider price as a dependent variable, and these different variables are independent variable, and use a linear regression to model it. Okay, so how I'm doing it? I'm going to my R screen, and my data set, I am placing it my working directory. So working directory, or just so you can download R. It's like freely available. Then can download R, can download R Studios. Once you have this, you'll open this. You'll have these kind of screens. So one is this where I'm creating my scripts. This is my console. This is my global environment. Whenever I like create any data set and all, I can see it over here, and any kind of plots and all, I can see it here. If I click over files, I can see how many files are there in my working directory, and different packages available. So there are all different things which I have in here. Okay, so let's read into my data. So the command to read this is my CSV file. I will read this in here. So okay, so okay, right. So let me fix first of all my working directory. So when I work with R, I need to fix this up. So this is a place. I'll do it. Now I have it. Now I'll start reading it again. Okay, now I have it. I have read all those things in over here, and what my data set, you can see it is 6259 observation and 11 different variables. And to read this, I have str command which tells me the structure of the data set, where you can see I have like price, speed, and all those. And this is also reading in this particular data type. It is int, it is factor. So factor is just nothing but a categorical variable. Okay, right. So all these things we have. Now if like you're doing it with me, or maybe you want to do it later, you want to compare those results, then you can set this up. This is just for R to tell that if you are splitting this data set, then randomly, then we start from here. Why I'm splitting it? I just want to split it up into two sections, where one is the training data set, where it helps me to build my data set. Second is the test data set, where I will evaluate my data set. All right. So this is the function, but to use this split function, I have to upload this particular package, CA tools, which can be used by library. If you are doing it first time, you have to also install it, and the command to do this is install.packages, install.packages, and you have to put that in quotes, and then you can install it, and then finally you can. So because it's already installed, I need not attach it over here, but this command you need to use it each time. So now I'm splitting my data set. If you see, this is my dependent variable. I'm using this. I have read this in data. Data is price, split ratio 0.7. It means 70% is my 70% data set I will read as a training data set, and rest would be my testing data set. Okay. Okay, so maybe I'll just look into questions. Just give me, let me complete my stuff. Let me get this thing done so that at least I have my agenda done and you guys are not left out with the objective of this session. So this is how I'm getting my training and test data set. So when I'm splitting it, I'm just marking this as true for this training data set and false as for the testing data set. Okay. Then, so I have all these different variables. Here, I can take a call, maybe one, based on my business, that what different variables could be useful to predict the price, and based on my business sense, I can start with this. So my first variable is speed, then I'll do plus, second variable is HD, plus third is RAM, then ads, premium. So there could be lots more. If I feel it is not right, maybe I can revisit my model. All right. Okay, so also just getting to the question of what is the optimal data set, optimal size of splitting into training and test data set. So it is simple. It is like if you have huge amount of data and you think that maybe 70% or maybe 50% of data is sufficient to train your model, then you can use that. But if your data set is small, then you left with no options. But you should have at least sufficient data set to build your model. So you need to do it based on your data availability. Generally, if you have a good amount of data, then you can go for 70 and 30. All right. And now the next part is building the model. So how do we do it? I'm doing it this building. This is LM is the function, linear model, just to build it. This is my independent variables, and I spoke I can do this, and I to mention data is equal to train. What it means that when I have created this training data set, okay, training data set I have created, I have subsetted this data based on my split. So if it is marked as true, it would be in training data set. It is marked as false, it would be in testing data set. And where have I marked this? I have marked this in this SPL command, sample.split and this. Okay. Okay, let's build the model. Okay, so this is my model. I have built my model. If I want to check my model, there is a command called summary and do my model. Okay, so I have this model with me. So the way I want to see it is this. I have all the coefficients. This is my estimate, this is my standard error, t-value, and all those things. And this stars is signify that more the number of stars, you can say that more like better it is to build this model. If I want to read this way, okay. So this is I'm creating my model, and if you would see my test data set, my test data set contains of 1849 observations here, and I want to predict for these many observations. Then I have to use a command called predict here, where the first parameter is model, the second parameter is the data set I want to give. Okay, so this is how it is. So I have predicted my values. So here you would see this is my, so there's two kind of values. So one, you would see my test data set. Okay, let me go this. So my test data set, if I have to call any variable, I have to use $, and the price data set is there, price variable is there, I will use this. So this test, all these price, the actual values are here. Okay, and the second kind of values which I have done it in predict test. So this is my predict test. How I have moved to this, I have just done like up arrow, and all these are predicted values. Okay, so these are my values, predicted values. And to check if my model, how healthy my model is, I just want to check that how far these predicted values are deviated from the actual values. For example, the first value here is 2259, and which is the actual value in my test data set. and in my predicted data set it is 2536. Okay, so I just need to check what is the deviation. So if deviation is huge, average deviation is huge, then I think that I should really go back and do some modifications here. I should be including more of the variables around here. There's a time I need to modify my model. So that was cycle which I have mentioned in my data analytics cycle. Okay, all right. Jumping into questions quickly. All right. So Imran is asking, what is prerequisite to learn R? Imran, prerequisite to learn R is, at least in Edureka, we really have nothing. We are not saying that you should have a programming background. If you really can build logic, if you are a rational kind of thought process person, then it's easy for you to learn. Okay, so one question is, what about SAS? Is it good? Yes, Mukul. So in fact, majorly the word was dominated by SAS, but now slowly R is picking up, and in fact, SAS has also integrated with R because R is open source and is quickly gaining popularity, and in fact has gained so much so that that the existence, slowly, organizations moving towards R because of its environment richness. Okay, next question we have. What will be the expectation from a fresher who aspires to become a data scientist? Okay, fresher is expectation would be at least to have a good know-how of technology. That's one, and a basic this technology as an R, R and all implementation, and then knowing those modeling techniques. Of course, business would come with the experience. Okay, so people who would want CSV file to execute this, maybe you really can ask the support staff. You can write to them; they'll help you with this. Okay. So, one question is, how do we read a single line? Okay, so if we have maybe if we have a single line in a CSV file, of course we can read that whatever is available in your CSV in whatever format. It can read any format. It's not only CSV. It can read the EXL format. It can read the text format. Whatever you want to make it read, it will read. And whatever is available, you can make it read and get into this data. Make it into this data which is understandable by R. All right. So next question is. Okay, so any reference guide for R? So reference guide, you see this, it's open source. You really can go around and get on the web. There are lots of material. People are really talking about R, and there is no standards. What standard there would be today, it would not be there tomorrow. They really keep on upgrading their packages and all, but the basic remains same. So there is a lot available over the web. Maybe a good searching would really help out here. And also, as mentioned previously, we are also doing this. If you would see our curriculum in Edureka, we're gonna do all these things. Introduction to business analytics. We're gonna start from there, and then do our programming introduction, manipulation in our data import techniques. Then we'll move into EDAs, do visualization. Then we talk about mining techniques, association rules. Then comes all this linear logistic regression, which we'll talk in detail. It was just a 1 hour session. Maybe later on, we can it's just more into it. We can maybe discuss more about that. ANOVA, predictive analytics. We also dirty our hands with little advanced modeling techniques of random forest and agent tree, and then everything would come to a closure. Everything would be related, finally boils down by doing a project. And with this project, we can relate all our topics into it. And if we are done with one more project, we would also provide with a certification at last. Okay. So this ratio of training and testing I have already discussed. Okay, so one question was how do we identify the dependent variable? So dependent variable, it really depends. So sales, we can understand. It's like what decision we want to take, what variable we think is dependent, what variable we want to predict for the future. Okay, so all these things you can consider for figuring out this. Okay, then okay. All right. So yes. So one was okay, linear regression. So to apply linear regression in R, we have this function called LM. This is a linear regression, and that's what we have implemented, what we discussed, and this direct function and all the computations were done in backend, and we without knowing it really can see the abstract. Everything is abstracted with one command R, and we can see the output just by typing one command, and then it later on only the dependability on us is just to interpret the output. Okay, that's a beauty of R. Okay, next question is how easy it is to implement R in Tableau. Okay, so Tableau comes with connectors, different connectors. So it is not easy, but saying that how do you connect it? Maybe what can be done, this R output, whatever it is, we can export that into a CSV file, which can be done by using write.csv command. And once we have that CSV, we can use that to read that in Tableau, and it becomes easy. The only thing is that we have to represent data in Tableau. Okay. Next is how can anyone interested in analytics switch to this field after a couple of years of experience in database SQL development? So guys, if anybody is like SQL and database RDBMS development, and then it would be quite easy, because at least you understand the database concepts. At least you have the basics that how this business is being captured inside the database. So that understanding is there, and your transition would become little like as in simpler. At least you have that background with you. But saying that if you also do not have it, then it's not a showstopper. You can any day start it, and for a fresh mind, it's always good. And experienced mind is all the better, because you also are coming with a domain and technical experience. Okay, so let me get into. Okay guys, so whatever, I guess some of you are asking this t-apply and all those functions. So it is because of this the agenda was not to understand the t-apply and all those functions of R. We have included all those functions in our courseware, and here was just to give a hands on it. But if you really want to do, maybe you can Google and get it up easily. But if you are enrolling with us, then also we would help you. In fact, not with only with t-apply, with all the family of apply functions. Okay, and so visualization, it's not only Tableau. We can use a lot of techniques to visualize it. We can use D3. We can use like HTML D3 combinations to do the visualization. Also can be used, just there are a lot of visualization tools we can use. It click view and all. Okay, so one is asking about the forum. Yes, so we can go to this. First of all, figure out this CRAN website, and you can see that there is one R blogger forum. You can Google for that, and you can get it there easily. Okay, so one is saying that one question is why do we want to split the data set? Okay, to evaluate if my model is built right, I need to split my data set. Okay. Okay, so other question is our topic is also covered in data science course. So maybe just check the curriculum, and partially we would be, but here in this course in detail, like at least the basics which would be required to do analytics, we are doing it. Next is so would be easier for DW and BI person to switch to it. So see, learning R is not at all a problem. Just person with good rational logical mind can understand it. Okay. Okay, so predicting in form of graph and chart also, yeah, we can do it. We have different packages in R. We can do it. Okay, so I think this topic was a little question was a little repetitive. R is also covered in data science course. Okay, yes. So maybe yeah, this in data science, the course there is a flavor of everything, not only R, the other things also. In here, if you would see, we're also talking about the modeling techniques and all. So I know that's what we discuss over here also. Okay. So websites to refer, yeah, we can also for modeling and all. Kaggle is one where we can do all the modeling competitions, and our blogger forum, and this stats learning. So all those things we can do it over there. All right. So yes, in this course we'll also discuss about the machine learning. Here you would see that we'll discuss different techniques, the basics of it. Also, we have advanced course of machine learning, but I would recommend that we'll go by the basics first. Okay. Okay. So anything else, guys? Since we are calling it a close, before calling it a close, we've already like 2 minutes above. But anything if you want to ask in the last minute questions, we can do it. Okay, I think that okay, so yeah, we have one. Can we do automation in R for data loading and cleansing? What will be the challenge in doing so? Okay, so automation, yeah, pretty much we can do it. If you see that your data is repetitive, you have same kind of data, you can automate it. You need not put your resources just resources in just out cleansing each time. If you think that one kind of pattern is there, you can automate it. Okay, so one is a question, when does a batch start for analytics? Please check over this course Edureka's website. You would find there are a lot of sessions. Maybe based on your convenience you can opt for one. One question is, can we write macros in R? Why do you need to write in macros in R? Because it's much more advanced than this. You need not that. Okay, all right. I guess this was it, and I hope you guys would be continuing with the quest to become data analyst, data scientist, and keep on learning. All the best.